Hello guys, here I am, your teacher Kansas, with my presentation on question and answer topic particle nature of. So one by one, I'll explain you and its answer with logic. You will learn how to analyze the question statement and how to find out the answer. First question: the diagram below shows the arrangement of particles in two different states. State 1, as particles are far apart, which is the property of gas, and in state 2, particles are close and it's orderly arranged. This is the property of solid. So, question is, what is the name of the process which changes the arrangement of particles from state 1 to state 2? Now, if we relate the concept gas to solid directly or solid to gas directly without going into liquid state. If we go solid to gas directly, this is sublimation. And if we change gas to direct solid, this is solidification. As the option of solidification is missing, so ultimately the answer will be sublimation. Condensation is referred to change of gaseous state or vapor state to liquid state, whereas state is not. Question number two. Which of the following graphs would be obtained on heating solid naphthalene to above its melting point? If you remember, melting point is the temperature at which substance completely converts to liquid state from solid state without changing its temperature. Therefore, if we carefully observe the graphs, B choice will be more appropriate because in case of B, there is a constant temperature for a while and then there is a rise in temperature as substance completely melts, changes to liquid. After changing into liquid, its temperature start rising. So answer will be B. Question number three: which of the following statements about the particles in a solid is correct? The particles are fixed rigidly about a fixed position. They are fixed position, but they are not rigid. They can vibrate about their position. Therefore, we reject choice A. And the particles are arranged in an orderly manner. Yes, this is the character of solid state in which particles are orderly arranged. So this is more suitable answer. Widely separated from each other? No, it cannot be. The particles are constantly rolling and sliding over each other. This cannot happen in case of solids. Choice is ultimately B. Question number 4. Which of the following shows the arrangement of particles in dry ice? Dry ice is solid. So in solid, it is evident from the diagram. Again, choice will be B because particles are orderly. Now the question number 5. In question number 5, we have to select which substance is liquid at room temperature. What is room temperature? 25 degrees. So melting point of C is minus 44 and boiling point is 346. It means this substance will be liquid at room temperature because room temperature is 25, whereas A is solid at room temperature, B is solid at room temperature, and D at liquid. It will be below room temperature solid and even below room temperature it is gaseous. So D cannot be the answer. Its choice is. So question number 6. Which of the following correctly describe the particles in a dilute salt solution at room temperature? Look at this. Close together, you may reject all options which are mentioning salt ions are close together. As I have shown in my previous video, when a solid is dissolved in solvent, its particles disperse through the solvent and they are widely separated. So A and B cannot be the answer. Widely separated, not moving, again it is wrong because they are widely separated and moving randomly. So choice will be D. Question number 7. A student set up an experiment as shown. In the above layer there is the dilute distilled water and below is bromine. This is bromine. So bromine is liquid. I have shown this demo in my previous video. Bromine and water molecules will mix together as they are moving randomly. So choice will be C, as both liquid particles are moving randomly. Which of the following process involves the absorption of heat energy? Boiling involves absorption of heat energy. Evaporation also involves in absorption of heat energy. So choice will be B. So this is the ninth question. The diagram below shows the mixing of 50 cm cube of ethanol with 50 cm cube of water. The final volume of the mixture was found to be 97 cm cube. Why is the total volume of the mixture not 100 cm? Because this is the common perception when two liquids are mixed together, their total volume of mixture will be equal to the sum of these two liquids. But you must remember that liquid particles have certain stresses between them and they can accommodate the other molecules. So those molecules which are accommodated or which are penetrated in between each other, they will not cause the increase in volume. So that's why volume is less than the total volume of the liquids. So we can select the choice. Ethanol molecules attach themselves. No, ethanol molecules fit into the spaces between the water molecules. Yes, choice will be B. So this is the answer. B. Now the question number 10. The graph below shows the freezing point of different mixture of lead and tin. As in my previous video, I mentioned that impurity lowers the melting point and raises the boiling point. So melting and freezing points will be same. Tin boils or or freeze at at 232 and lead at 327. Whatever the mixture proportion. This is indicating the percentage of lead. If you add small lead in tin, so its melting point will be below 230. Again, it is decreasing. But in all cases, the melting point of mixture will always be less than 327 melting point of lead. So its choice will be C, below that of lead. Question number 11. Substance X melts at minus 107, minus 7 Celsius and 59 is the boiling point. At which temperature will substance X be liquid? So it will be liquid between minus 7 and 59 because at 59 it will be boiled off. So the temperature between these two degrees is 0 degree. 0 is above minus 7 and below 59 degrees. So answer will be B. When solid iodine sublime means converts solid to gaseous state directly on heating. The iodine particles do not break, nor their size will change. They will absorb energy, not lose energy. So the ultimate answer will be D because particles become far apart and they fill in the space of the existing container. not correct. You have to select the not correct answer. The air particles are distributed very far apart. As we know that gas particles are far apart, yes, but it's distributed far apart in orderly manner. Orderly manner is arranged in regular pattern, which is not possible for gas. The air particles are held together by very weak attractive forces. Again, this is the case where this is the case we have to select this statement is not correct about the gases. The air particles have high kinetic energies. The air particles are in constant motion. They are in constant motion. This is, both statements are correct. So not correct. The air particles are held together by weak attractive forces, far apart, orderly manner. So choice could be attractive forces are held very weak attractive, so they cannot be. So the more closer option is A. In this case, A could be the answer because they are far apart. This is also a character of gas, although they are not orderly, but as in the given choices, this could be the choice orderly manner but far apart. Weak forces could be present, kinetic energies are high, and we were supposed to select not correct option. So that is the question number 14. In the diagram above, balloon filled with hydrogen gas deflates. Deflates means gas will escape or leak, and deflates faster than the. So hydrogen is lighter gas. It diffuses at faster rate than carbon dioxide. So choice is ultimately C, as hydrogen is lighter than carbon dioxide. This was the option. Now it's about the structure. So I'm numbering the options because I have to select words. 2, 3, 4, 5, 7. Instead of words, I could even tell you the numbers. Iodine crystals to iodine vapor. This is sublimation. So sublimation number is 7. Water 100 degree to steam 100. So this is boiling. Boiling is a third number. And ice to water. This is freezing, melting. Sorry. This is fourth number. And petroleum gas to liquefied petroleum gas. So this is condensation. Condensation is first number. Ethanol is an organic compound found in alcohol drinks. Its melting point is minus 170 and its boiling point is 78. What is the physical state of ethanol at room temperature? It will be liquid. So if liquid is not mentioned, so I as room temperature is 45 degrees. So as it melts at minus 170, so above 170 it will be liquid and above 78 it will be a gaseous liquid. Draw in the boxes below the arrangement of the ethanol particles that you would expect at minus 100 degree. Now remember at 100 degree it will be in liquid state. At minus 100 because it melts at, so in liquid you can draw the random particles at different abrupt, I mean not in order. And at 100 is much above its boiling point, so you can draw the 2 as state at 100 will be gas. Now it will be interesting question. At What temperature would the arrangement of ethanol particles at -100 degree change into the arrangement at 100 degree? It means it's asking about the boiling point because at 100 it is in gaseous state and at minus 100 Celsius it was a liquid. So therefore, for at 78 degree it will convert into gaseous state which will be same as at the 100 degree. So your answer would be 78, 78. Describe the arrangement of the ethanol molecules at -20. At -20, its melting point is -117. Therefore, at -120 degree, it will be solid. So you have to draw its arrangement as a solid regular pattern. I'm not going to draw it here, but you will remember that it will be in solid and you will draw the regular arrangement of particles. The graph below shows how the boiling point of water changes with pressure. From the graph, deduce how the boiling point of water changes with pressure. As pressure is increasing up, and its temperature, its boiling point at this temperature, at pressure is high, boiling point is also high. From the graph, it is evident. Determine the state of water at the following point. P. At P state. P is higher pressure, and at this pressure, it will be in liquid state because it will be at this. If this is the pressure, this would be the temperature at which it boils, as pressure is much above its boiling point. So, for the graph, this will be the boiling point. Yes, so it will be liquid at this temperature because it has to be boil off at much higher temperature at this point. At Q, it is in liquid and vapor state because Q is on the curve. At R is below, temperature is high. At this temperature, it will boil off, so it will be gaseous state at R. This is how you will determine the physical state. Explain why changing a liquid to a gas requires a large amount of heat energy. In liquid, particles are connected together through attractive forces. So first of all, we have to overcome the attractive forces which are overcome by providing heat energy, which increase the kinetic energy of particles. So liquid gas to sketch a graph show how the temperature of the water changes as it is heated from room temperature to 110. So you have to draw the heating curve. Potassium metal melts at 64 degrees and boils at 774 degrees. By changing its temperature, potassium can be made to exist in the solid, liquid, and gas stage. Describe briefly the arrangement of movement of particles. So at 64 degree it melts, below 64 it will be solid. When it melts, it will be just like a liquid. And at 774 degree it boils off. So you can write the gaseous state diagrams to represent the gaseous state. So there is a small space, so I'm not drawing, just watching. Below 64 it will be solid. You have to draw the solid element. 664 it will be solid and liquid both. As 778 it start boiling off. So it means at 774 it will boil off. When it boils off completely, it changes to gas. You can write the 360 again is required. Describe briefly the arrangement of movement of potassium particles in the three states. Again, three states you are supposed to solid, liquid, and gaseous state particle movements and their arrangements. So, potassium metal is heated from room temperature to use the kinetic theory to explain the changes. When a substance is heated, it absorbs heat energy and its kinetic energy start increasing. When it reaches up to the boiling melting point, the forces are overcome and its movement is achieved in liquid state. And when it further heated, it converts to gaseous state. It means you are supposed to describe the movement of gaseous particles. The following observation: when a small quantity of uh, ether is placed on the back of one hand, a cold sensation is felt. When ice is heated, the temperature stays constant at 0 degree. So ether has low boiling point. So it absorbs the heat energy of body and escape. So vapor evaporation cause cooling effect. Ice when melts, heat provided to ice is used to overcome the molecular forces and it changes from solid to liquid. So temperature will not rise, but only the state will change. When 1 cm cube of water is heated, the volume of steam obtained is more than 1,000 times larger, as steam is in gaseous state and gases try to occupy the available space. Therefore, particles are far apart and move randomly to more space than the solid particles. A solid is rigid, whereas gas is highly compressible. Solid particles are tightly packed together. There is no space between the particles. That's why they are rigid. And gas particles are far apart. There is a space between the particles which can be compressed. Now the next question: describe the arrangement and movement of the particles in liquid X. Particles are moving randomly. They are in groups, slipping each other, moving in all possible directions. Liquid X is heated again. Liquid X is heated. Liquid is heated. Its kinetic energy will increase, and ultimately it will reach to its boiling point, and particles fall apart from each other as the temperature cools. How does the movement change as the liquid boils? When liquid boils, particles are randomly motion occupied occup- all available space. So the gas properties you have to mention. Draw the arrangement of the particles of X in the gas state. Simple gas model. Just draw a box and few particles can be mentioned. Bromine is red brown liquid at room temperature. Describe a simple experiment to show the bromine is made up of small moving particles. Yes, the diagram below can be demonstrated to show the particle movement. Actually, you have to show the diffusion experiment. You will place the bromine in cylinder and an empty cylinder above the bromine cylinder. So after some time, the above cylinder will also fill with the red brown fumes. That is also mentioned in my previous video. The experiment was in detail discussed in detail. Carbon dioxide is dense gas, hydrogen is very light gas. In the diagram below, draw the arrangement of particles of the two gases 30 minutes after the gas cover is removed. So both gases mix together because all gases or materials diffuse from high concentration area to low concentration area. What is diffusion? The movement, spontaneous movement of particles. particles from high concentration region to low concentration region, that is called diffusion. If a few crystals of copper sulfate salt are placed at the bottom of the beaker filled with water, the blue color of salt will spread to all parts of the water space. This is the movement of solid and liquid particles towards each other, and therefore the solid can dissolve and disperse through electromagnetism. This question is similar to the MCQ we have done in multiple occasions. You have to plot the graphs, and then you will. I'm just going to roughly draw the lines, but you have to draw yourself. This is the percentage mixing, and here will be temperature. You will plot the scale, right? So one graph will be like this, and the other side will be like this. So you will mention the highest temperature is 327, and this is 232. So this is the freezing point of the highest, most freezing point. So this question is exactly the theoretical version of the MCQ as we have done in the MCQ section. State the composition as disclosed. This composition can be noted this percent of lead, and the other is the tin. You have to describe the chemistry of tin and lead at this point. How does the addition of tin and affect its freezing point? Of course, freezing point decreases impurity, at boiling point increases impurity. So when both substances or elements are mixed together, their melting point must be less than the highest temperature, that is 227. So with this end, I hope you understand the question and the topic. And see you in the next video. Have a good